In example 26, we're going to get a look at what our matrix looks like when we're working with a system that perhaps might have no solution or infinitely many solutions. How can we tell that we're in that situation when we're working with a matrix? And so here we have our system of equations. We're going to start out, as usual, by just writing the augmented matrix. Now we want to get a 1 right here, and we'll do that by multiplying by the reciprocal of that entry, so minus 1/2 times row 1 into row 1. Row 2 is unchanged. See, row 1 is a 1. Minus 1/2 times 6 is a minus 3. So we get a minus 3 in both those entries. And now we want to zero out the entry below that 1. So we want to get a 0 right there. And because we have a positive 3, we can obtain a 0 by adding negative 3 times row 1 to row 2. Putting the result into row 2. Row 1 is unchanged. Now let's see, when we add negative 3 times 1 plus 3, that'll give us 0 right here. Negative 3 times a negative 3 plus negative 9, that's a positive 9 plus negative 9 is 0. And here we have, again, negative 3 times negative 3 plus a negative 9, same operation, we get a 0 here. Now, we know something fishy is going on when we get all zeros to the left of that vertical line, because we also got a 0 to the right, so we have an entire row of zeros right here. That tells us that there are infinitely many solutions. So the 2 zeros here tells us that we need to stop. And we have a row of all zeros. Tells us that there are infinitely many solutions. It's similar to when we solved a system algebraically, and whether using substitution or elimination by addition, reached an equation that looked like 0 equals 0 or 2 equals 2 or something. In this case, this is sort of the equivalent of 0 equals 0. It's always true no matter what x and y are. So there are infinitely many solutions to this system.